Howdy, this is Nick with Hylio. I am back again with another operations manual video. This, I believe, is the fourth video in our operations manual series. This one is going to be a doozy, may end up the longest. We're going to be going over the UAS settings. So we're going to talk a little bit about what each of the settings are, what they do, and then we're going to go through recommendations for how you should choose each setting, and lastly, kind of how that's going to look with different drones. So just to give you a little heads up, this is all the settings we got to look at. Looks like a lot, looks like it's a little overwhelming, but we'll go through it. Hopefully it won't be as confusing by the end of the video. To get started, before we get into kind of each setting, we're going to briefly talk about some of the really important stuff for picking nozzles and just spray recommendations in general. A lot of people maybe spray with tractors, not with drones, probably not. A lot of people maybe never sprayed at all. So we're going to talk a little bit about nozzle tips. We're going to talk a little bit about how you're going to choose some of your settings to do a required application rate as far as like gallons per acre. We're going to talk about drift a little bit and spraying in the wind, and then we're going to get into some of the specific settings. So first off here, nozzle selection. So our drones will go out with one of a few different nozzle types, just depending on the drone. Honestly, just depending on when it went out too. So you may have something slightly different than what's being read off here, just depends when the drone went out. We will usually send out either a TJet AIXR or a TJet TTI or a Greenleaf air mix. It's almost always one of those three, either a ceramic or a plastic tip. The AIXR and the air mix usually are a little bit better for herbicides, for more of a coarse droplet. This coarseness of droplet is going to lead to a little bit more of a narrow pattern. So if you're doing herbicides and you want to really focus on making sure that you don't have drift, you're probably going to want to stick with these AIXRs or these Greenleaf air mixes. The TTI is maybe more of a all-purpose nozzle tip. So TTI is more of a medium range droplet size. And then lastly, we do offer some hollow cone tips. I forgot what the prefix is for that, but those hollow cone tips are going to be generally on the finer side versus these options here. So depending on what you're spraying, you may want the more fine or the more coarse droplet. Like I said, you want the more coarse droplet to minimize risk, but it's going to bring your swath in. You want the more fine droplet if you don't really mind drift as much, because say you're spraying a fungicide and it's something inherently pretty safe, but with a fungicide, it's that contact really matters a lot. So having a lot of droplets per square inch matters more. So if you are doing a fungicide, I may recommend switching out an AXR or a Greenleaf with a TTI style tip, or even go all the way to cone, but at least maybe go to TTI if you're doing fungicide. Just will help with the pattern a bit. Just a quick nozzle overview in general on nozzle tips. You can buy them anywhere. You can buy them at Tractor Supply, or you can buy them from us. It really doesn't matter. The first few letters here, say TTI, AIXR, this is going to be the tip type. So that's what I've been talking about with the hollow cone, extended range, turbo TJet air induction, stuff like that. Then the next few numbers, this is generally either an 80 or a 110. This is the angle at which the fan comes out. This doesn't usually matter that much with drones anyway. With tractors, it's a big deal, but with drones, doesn't really matter that much. And then the last couple of numbers, either 2 or 3 numbers, is going to be the orifice size. So this TTI can come in an 01 size, 015 size, 02, 03, 04, 05. This number is an estimate of the gallons per minute that will come out of this tip per tip. So if I've got an Ag 30, for example, with 16 of these O1 tips on there, I can expect around 1.6 gallons per minute. If I move up to a 0.15 size on my Ag 30, I can expect around a whatever that is, like 2 point something gallons per minute. Generally, with the ones we send out there are, as far as the orifice size, we try to kind of optimize it for the drone. The finer orifice is going to have a little bit smaller particles than the larger orifice. Now, I would recommend, again, taking a look at what you're spraying. If you want a little bit of a higher flow rate, you can increase that orifice size. Just got to keep in mind, though, if you go too big, the pump probably won't be able to keep up. I mean, obviously, I can't just throw a 0.6 on here and expect the pump to be able to put out 10 gallons a minute, because the pump can't spray that fast. So you are kind of limited by that. This is a nominal rate based off of the pressure that the pump is putting out. And these pumps will put out about 60 psi, but if you at the maximum, each pump I think does, I don't know, a little more than a gallon a minute. So at the end of the day, you can't get much more than, say, 3 gallons, at the most. But so just depending on what you're doing, select the appropriate tip for what you're trying to spray based off particle size and desired flow rates. All right, so next section we're going to talk about is how you are going about picking your speeds. And basically, we're kind of cutting ahead of some stuff here, but it's kind of important to know right now how to do this, because it's a little bit independent from what all these settings actually do. But I want you to imagine that you're going out to go and spray with a drone. You want to go and spray 2 gallons an acre. That's a really common application rate for aerial applications, so we're probably going to use that for the rest of this video. So you want to go out and spray 2 gallons an acre because that's what it says on your label. Now, first of all, how do you even do that with the drone? There's a few different options. The drone, you can spray with just a constant pump rate. You can just dial the pump up to 100% and it'll just spray a flat 100% all the time. You can also tell the drone to use its flow meter and spray like 1.2 gallons a minute, effectively similar to the percentage, just a flat rate, it just sprays it all the time. Or last option that our drones have is a gallons per acre selection. So it's a dynamic flow rate selection. Now, when you're spraying with a dynamic flow rate, and again, don't get worried about this stuff, how to do it. We're going to get into that, and where to choose these settings is in the software manual. So let's pretend, because this is what almost everybody does, we're going to do a dynamic flow rate of 2 gallons an acre. So the drone is going to regulate its pump output in order to hit 2 gallons an acre, because part of the field the drone is flying slower, other part it's flying faster, just because of the nature of turning corners and stuff. It's not always flying at that same speed, but you want to have an even application rate. So we want to hit 2 gallons an acre, right? Well, the drone can fly 20 miles an hour. So what is to stop us, the user, from saying, oh, I want to spray 20 gallons an acre and I want to go 20 miles an hour? Obviously, the drone is not going to be able to keep up with that. It's not spraying enough fluid out to actually put out 20 gallons an acre going 20 miles an hour. There's some math here that's going to need to get done so that the drone can actually put out what you're telling it to. So we added a little calculator into the software so that you can pick a optimal speed for the drone to spray at to hit a desired application rate. Now, this is where things can get kind of confusing because there's a lot of stuff in the air at one time right now, a lot of variables going on. But this section here, we're going to just, go through how do you go and pick that flight speed so that you are flying as fast as possible, because you want to be as efficient as you can, but also not flying too fast so that the pump can't keep up. So step one is we're picking our total volume of gallons per acre that we need to apply. 2 gallons an acre. That's what most people are going to be doing. Simple enough. Step two, we're going to choose a pattern width to spray. So this is a little variable. I'm going to give recommendations later here about what pattern widths to choose. In general, pattern is going to get wider as you fly higher and as you do more gallons per acre. It's also going to get wider based off of your tip selection. Again, I'm going to give examples and how do you understand what that probably will be later in the video. But for the purposes of this, we're going to choose, let's just call it 18 feet. So I think that's pretty normal for a 30 or a 16 or a Ag 30s go 18 feet. So we're going to do 2 gallons an acre and we're going to do 18 feet. Okay. And again, this is to pick our flight speed so we're going as efficient as possible and not outpacing our pump. So step three, if the whole point here is to not outpace our pump, we need to know how, what is the max that we can do with this pump. So essentially step three is to run our pump to the maximum on the ground, just setting it to 100% pump power. This, you can look up how to do this in the GCS manual. You can do it through the software or through the controller, but basically you just run the pump on the ground to 100% for 5-10 seconds, and you're going to look at what the flow rate the software reads out. So this is just to know what you can expect, because to calculate our speed we need to know the most our pump can actually do, and this is going to change with some chemicals if they're very viscous, or if you change to different tips, that's going to change this. So you're going to want to know what this is. You don't need to test it all the time. I mean, honestly, in general, it's usually around like 2 gallons a minute, roughly. It's going to be different on each drone, given what you got in there. Okay, so first, got our gallons per acre. Second, we picked a pattern width that we're spraying. Third, we have our pump maximum flow rate. Now, we can, with those 3 bits of information, we can calculate how fast this drone can go before it outpaces that pump. So if you go to the maintenance tab, there's this toolbox speed calculator here. Is a similar calculation for solids. But basically you type in those 3 things: desired dosage, gallons per acre, swath width, say 18 feet, and maximum flow rate in gallons per minute. You type that in, it's just going to tell you a maximum speed. Generally, it's probably going to be maybe 20 miles an hour. I would mess around with this calculator when you are trying to decide what kind of tips you want to use and what kind of rates you want to spray. You'll find out very quickly that how quick you can pump out chemical, and based on your tip selection and all of this, makes a huge difference to how efficient you're going to be with this drone. Bear in mind, the drone, really any of them, can fly 25 miles an hour for the most part. It does take some time to get up to that speed, but just keep that in mind. If this maximum speed here is 35 miles an hour, and you can only go 25, you're really not being that efficient. You want this maximum speed to be 20, 23 miles an hour, something like that, so that the drone can go at an efficient pace. Anytime that you are flying less than what this maximum speed calculator puts out, for whatever reason, I mean, maybe you just need to spray 10 gallons an acre, or say you want to spray 1 gallon an acre, let's say. This maximum speed might come out to 30 miles an hour. You're not going to be as efficient because you can't fly that fast. Now, this is extremely important if you are doing something like 10 gallons to the acre, 5 gallons to the acre, because you can probably only fly 6 or 7 miles an hour before your pump can't keep up anymore. So, maximum speed calculator here is very important. I would use this anytime you're spraying, not only to make sure you're not outpacing your pump, but also just to make sure that you're being as efficient as you can. If you're going out there flying at 15 miles an hour and you could be flying at 23 miles an hour, over the course of the day, that makes a huge difference in what your drone is going to get done. So, moral of the story here, use the maximum speed calculator. One last thing about drift here. There are some additives that you can use. Our preferred one that we like to use called Windfall. You can use a number of different ones. Just pick an adjuvant for an airplane, and the chemical companies don't make stuff for drones right now in particular, so you can use kind of stuff for planes and helicopters will work just fine. If you use these adjuvants, they will make a big difference to mitigating drift when you're spraying at a low volume, especially if you're going out and you're spraying a herbicide at a low volume, which is generally not legal. Usually herbicides require like a 5 gallon per acre as opposed to a 2 that you see on fungicides and other less toxic chemicals. If you're doing a herbicide, especially if you are doing a herbicide lower than you should, then you really should get one of these adjuvants in there to help make sure that you're not having drift. In particular, if you're going with one of these other tips like a cone, hollow cone tip, and you're going to have a lot of fine particles, you're going to want to use this. And last one, just a quick note about spraying with wind. It's not a huge deal, but whenever you can, you want to be having the wind coming across you. It seems a little, counterintuitive to some people. Generally, just what we've seen is when you're flying into the wind versus with the wind, it can kind of narrow and widen the pattern a bit to where you'll sometimes get this situation where you'll have a lot more streaks throughout the field when you're going towards the wind, because it just like messes with the pattern, versus if the wind is coming across your pattern, then it kind of shifts just the whole thing one direction and it just ends up a little bit better. So if you're spraying with wind, especially if you're spraying in more wind than you should be spraying in, this is generally a good way to do it. Moving on here to the next section, we have the UAS and mission settings. So these UAS and mission settings can be broken down into the different tabs where they appear in the software. We're going to utilize the software for this section of the video, not necessarily to explain how to use the software per se, just to help you remember what we're talking about and just give you something to look at. It will, I think, make some of these concepts a lot easier to understand when we're kind of looking at them. We're going to go through the settings one by one, what they do, and we're also going to, one at a time here, jump down to those down here in this recommended settings chart to, give our recommendation for each one, kind of talk about what you should set them to and why. So we're going to be jumping kind of up and down as we go here through this chart. So getting started, the first setting we have is in the areas tab. That would be buffer. So this buffer, let's go ahead and pull up the software here into our areas tab. Buffer can be found in the broadcast and perimeter layer types. Buffer is essentially the distance that the actual flown area is from the drawn boundary. So you can see here I can reduce this buffer to something very small, so the drone is actually spraying right up next to this boundary, this green box, or if I increase it quite a bit, it backs it off. Now, the reason for having this is basically so a pilot can draw this green box here to where he thinks something is safe, he or she, and add this buffer to generally it's for over application, so drift, if you think you're going to have a lot of drift. Other option is for GPS accuracy. So if you think your drone is particularly not very accurate in this case because you're not using RTK, or if you're just drawing based off Google Maps and this map is very old, you can use that to, okay, I'm going to give myself some extra room here because, I don't know, I think this tree has moved quite a bit, this map is pretty old, or I'm not using RTK, I think I have a lot of GPS error. Essentially, this gives you some safety margin around the edge of the drawn area. So that's buffer. Same thing is going to apply for that broadcast layer, which is this lawnmower versus this perimeter layer. So we have buffer here as well to just pull you in from the outside like that. Next up here we have our swath width. So swath width, just jump down. What should we set this buffer to? So, what is a safe number for me to choose this buffer? Now, generally, we're going to want to be at least about 20 foot on all of this, just as a safe starting point. Now, the reason for that, and that's across any drone, the reason for that is you can generally assume that the drone may have about 10 foot of GPS error. Just depending on what's going on, you're usually going to have at least about 10 foot. In the worst case, it may be better, maybe worse, but to consider the drone being off by as much as 10 feet keeps you out of trees a lot more often, or keeps you from kicking your OA on to dodge trees. So that's 10 feet. You can also assume that this map here itself can be off by as much as about 10 feet. Google Maps isn't perfect. The GPS is not perfect. So if you essentially add those two together, you'll get this 10 foot of buffer. If we had drawn this area right up to the tree like this, we can assume, okay, maybe this is 10 foot off and maybe the drone is 10 foot off. Worst case, I'm actually right up next to that tree, but I'm not in it. So recommendation here on buffer, 20 feet across the board. This one's going to be kind of variable. If you're using RTK, you can bring it down a bit. If you're using RTK-based maps to import these shapes, you can bring it down a bit as well. If you know that this Google Maps is super outdated because that tree has grown a lot since then, maybe you're going to want to increase your buffer a little bit. But 20 foot is a good starting place. Increase or decrease based off of what you got going on in your specific case. So next one here, we have our swath width. So swath width shows up in the broadcast, perimeter, and spline layer types. Swath width, it's the second one here. Pretty simple. It's basically the distance between the passes on the pattern. So nothing too crazy about it. You'll see it on perimeter because if we have multiple passes on the perimeter, and spline as well, if we do multiple passes on a spline, how wide apart are these going to be? So how are we picking this swath width? So jumping down here, back into our recommended settings. For our Ag 10s, we start you at 14. Ag 10 or Ag 16 puts you up to 16, 18, and 30 for the big one. Now these numbers in general came from our testing with the USDA. We put something in here that was going to be a safe starting point. We have a lot of customers that fly at a lot higher widths than this, but if you've got a lot of adjuvants in there to really reduce drift, and if you've got, say, some different nozzle tips that are going to go straight down, this is going to be a safe place for you to start with. Now, if you want to increase it, I'd recommend doing some spray pattern testing using hydrosensitive cards. You can just buy them on Amazon. They're not super cheap, but this is a good starting place for you. Again, a lot of stuff is going to affect this. If you're flying higher, this is going to get a bit wider. If you're flying lower, this is going to shrink up a bit. This recommendation here is for if you're doing at the altitude and rates that are included in the rest of this chart here. So about 2 gallons an acre, 20 miles an hour, 13 foot altitude, then these widths are going to be pretty safe for you. If you go down to 8 foot spray altitude, then maybe this isn't going to apply anymore. You might want to bring this in a little bit. So that is our swath width. Again, picking it, just start with what we give you, kind of go from there. Next one here, spray angle. So this one's really easy. It's really just in this broadcast one. Angle is the angle of these lines. So you see how it's kind of turned one way versus being straight, the other way. Nothing much to it. People usually will just leave this as whatever comes out to. The software is just going to pick as efficient as it can. Sometimes if you have a really complicated shape, it can be better to, change that angle to optimize it. So if I do something kind of funky here, it may have a hard time, figuring out how to do this weird shape. So sometimes changing the angle can kind of help the software to figure out a good way to spray this area. Looks like we had one there when it went green. Oh, there you go. So you see how we worked the angle a little bit, and then now the software did a decent job. It could figure out how to spray this. So angle, some people will use it for that, just for efficiency's sake. Some people will choose to line up with the corn rows or something like that of whatever they're planting. You can do that too. I don't know how much benefit there is to it, but that's what angle is for. Next one, so angle, I'm not sure if I even have a recommendation because it doesn't really matter. Yeah, angle and offset here, we just put anything. So next one, oh goodness, lost ourselves. Next one, offset. So offset, similar to angle. Here we go, we'll bring it back up. This, instead of turning it, this shifts the lines left and right. So you see how the lines are kind of, if I decrease the offset, they're just shifting one way or the other. Now, there's a few reasons that you might do this. Main reason being, if I have, say, this situation here where, the drone is just going to generate as many lines as it can. Let's take the buffer down to 0. Why is it having a hard time with this? Oh, that's a dang obstacle. We'll increase it a bit. So basically, you can see here that if my buffer is too low, see now I'm down to 8 feet, I'm actually spraying outside of this area right now. So you sometimes may want to use this offset, understanding that the software won't generate another line until there's actually the appropriate spacing to add one. So if you're really particular about the edges of your fields and getting things just right, you may have to use this offset to get what you want. At the end of the day, the drone is just the software is just laying down a grid pattern. If you want some really specific stuff on your field edges, you're probably going to have to utilize this offset and angle to get what you're looking for. All right, so that was offset, not too much there. Next one, passes. So this is just for the perimeter and spline. So we'll just look at perimeter. You can see here where perimeter is basically just going in a pass around the edge of the field. There's a lot of good reasons you might do this for safety, just to stay farther away from the edge. So you can see here that we're actually spraying all the way out here, even though we're not flying nearly as close as we would have to with this. So that edge is getting sprayed just the same, but on perimeter, the drone is way farther away from that tree line. So definitely something to consider using these perimeter passes. But anyway, number of passes basically tells the drone how many times to fly around the edge. Same thing if you're using a spline layer. So spline is basically just flying along the line. If you were doing a waterway, let's say, something like that, if you wanted to fly however many passes along it, that's what this does. So next one, orientation. And again, just like, our offset and spray angle, the number of passes and orientation and stuff like this, not really going to make a recommendation, just depends on what you want to do. Doesn't really make sense for me to recommend something if, it's not always going to make sense for you. So next one here, we have orientation. You can essentially choose if the drone is going to fly clockwise or counterclockwise, as it goes. Just always be aware, the play button is a start point, so it's going to fly from that direction. So, yeah, pretty easy. And it's the same thing for the spline option. All right, so that was it for our area settings. Essentially, all the settings that we're using to dictate how these lines are going to go. Now, the next section that we're going to talk about here is the application settings. This is where we're going to get back into those recommendations quite a bit. So, first one here is our spray altitude. So, choosing an appropriate spray altitude is going to be very important. There are some minimum safety margins that you want to make sure I'm, at some safe level. And then there's also just being optimal, as far as your pattern width and stuff like that. My recommendation, as a good starting point, if you're spraying, say, some 8-foot corn or something like that, is 13 feet. 13 feet is a very good starting point. If you go much lower than this, you're going to bring that pattern width in a little bit. Pattern's not going to be as even. The only real reason to be going lower is to reduce drift, or you've got a lot of wind, something like that, in which case maybe you can. But generally 13 feet up to about 15 or 16 is kind of where you want to be. And that's going to be the same across all the drones to help you get to this pattern here. Again, you want to increase that swath width. You're trying to push it a little bit just to be more efficient. Then, maybe you can increase that altitude a little bit, or just for safety. So as far as in the software here, we've got our area. Now we're going to be spraying corn, let's say. And let's just say we're doing some fungicide. Insecticide, I guess. So spray altitude, that's this first one here. So we can do, say, 13 feet. That's a good, nice starting point. That's how you pick it. You don't really see anything visually. That's just how it shows up here. So we're talking about, obviously, 13 feet's a good starting point to be at. As far as bare minimums, safety-wise, you're going to want to always be at least a few feet higher than anything that you're spraying. So let's say you are spraying some 8-foot corn, or you're spraying a 12-foot brush. If you're spraying a 12-foot brush and your drone's spray altitude is at 11 feet, you can see how that might cause us some problems. Maybe you're flying over the brush and that's all fine and dandy because I'm 11 feet over the brush, but especially with brush, there's a lot of gaps. So let's say I go off the brush and now I'm 11 feet off the ground and I'm trying to get back into the brush again. Brush is 13 feet tall. Well, now we're relying on our obstacle avoidance from keeping us from hitting that brush, which is never a place you want to be in. So what that tells us is no matter what you're spraying, you need to set this spray altitude to be at least a few feet higher than whatever it is that you're spraying. So if I'm spraying 8-foot corn, I need to be at least 11 feet. If I'm spraying 15-foot brush, I need to be at least 18 feet. Now, if you don't follow this, then if there's any gaps in the area that you're spraying at all, then you are putting yourself into a situation where you might have an accident. So bare minimum, just totally separate from our actual recommendation. I prefer to be, 13 to 16, somewhere in there. But no matter what, whatever you're spraying over, you got to be at least 3 feet more than the height of that crop. All right, so next one here, spray speed. So we already talked about this a little bit, just in the software here. We got our spray speed, easy enough. How you pick that speed and what it should be is, you're going to want to use that toolbox calculator. So I have in the chart here a spray speed that was determined using that calculator at the normal pump output. As we talk about using the toolbox calculator and that maximum output from each drone. So I use that to calculate the spray speed in this chart with just a normal maximum output. So if we're at our, we'll pretend we're using our calculator right now. We put in 14 foot for our swath. We put in we put in 2 gallons an acre, 14 foot for our swath, and whatever it was that I put in for maximum pump rate, we're going to get 19.5 miles an hour. So if you find yourself doing 2 gallons an acre and you're not kind of somewhere in this range of speed, you may need to check what you're doing. But picking your spray speed, just use that toolbox calculator and you really can't go wrong. Just try to stick a little bit under whatever that thing comes out to. Next one, spray mode for the application here. So we got 3 options: dynamic, static, and fixed. So dynamic is going to be a gallons per acre selection. So whatever you want to do, gallons per acre. we're going to probably stick with 2 because that's where we do most of them. Static, you can say I will just want to do a flat 1.5 gallons a minute, or fixed, I want to do whatever, 100%, something like that. Now, yeah, that's how you pick it. The one under it here, we have our spray mode and our spray rate, so we're kind of looking at both of those right now. This is the mode, and this one is the rate. Now, dynamic, this is what pretty much everyone does all the time. Dynamic 2 gallons an acre, that is where 95% of our customers are at. It just helps you get an even application rate. Now, if you are one of those that are super picky about your particle sizes, maybe you've been in ag for a long time, you've been in spraying for a long time, and you do a lot of herbicides, so droplet size is really important to you, then we have people go with fixed power, which is essentially basically like choosing a pump pressure. So you can be a little more certain of your particle sizes and stuff like that, because when you're in dynamic, the drone is essentially going to vary that pressure based off of your current flight speed to hit this gallons per acre rate, because it's not varying its pattern width or anything. It's not going to vary its speed. It's just going to vary that pump pressure. So again, this is where most people are. People will use this fixed power often just if your flow meter gets clogged up or broken or something like that. For whatever the reason, you didn't clean your drone out very well and your flow meter gets jammed because you let a bunch of nasty chemical dry in there, which is probably the most common time those ever get broken, is people don't flush it out, and you get chemical dries up. You may want to know where this pump power is, because this is the only one, that doesn't use the flow meter. So at the end of the day, you can always still spray even if you have a broken flow meter. That's most commonly what that pump power is used for. Now, next one up here, we're getting into some of the more particular settings. This is about a spot mission. So we've got cruise altitude and dosage here. So the spot mission is essentially a bunch of individual coordinates like this, where the drone is going to fly one at a time. It's just going to go park over top of 1, spray a certain amount, and then go to 2, spray a certain amount. It's just going to sit and just dump whatever you tell it to do on each one. So we've got our cruise altitude and dosage here. Cruise altitude is basically the altitude that you're flying between 1 and 2. So you've got your altitude, your ferry and RTL altitude we talked about before. You're going to ferry out to 1 at a certain height, and whenever you're done, say with 7, you're going to go back at a certain height. But what height are you going to go between 1 and 2? So that's what our cruise altitude is here. Then our dosage is how much we're going to dump on each of these little spots here. So depending on what you're doing, that number will be different, of course. So jumping down to our recommendations on some of this stuff, because we finished the broadcast settings, into the spot settings. So spray altitude, we just left this the same for all the same reasons. Cruising altitude, 15 feet, just to be a little higher than your spray altitude, just to be safe. You can leave it at the spray altitude, but nice to give yourself a little room. And lastly, dosage. So you're going to want to do the math here, based off of estimated square footage that you're spraying on each spot, and what application rate you want. Generally, when you're looking at herbicides for like brush or something like that, I think you're able to get up to, I'm trying to think, you can generally triple or quadruple your broadcast application rate, which you kind of need to, because if you're going to park in one spot and spray a half a gallon, you are going to absolutely destroy what's under that drone. So normally, under most situations, if you're mixed up for a kind of regular 2 gallon an acre rate, depending on the chemical, you're probably just looking at that like 0.1, 0.2 gallon range. Again, going to totally depend on the chemical, but if you do the math and it comes out that you're spraying a half a gallon, 3/4 of a gallon on an individual spot, I would go double check your math, because in most cases that's not gonna be what it comes out to. So next one here, jumping back up, we're probably into the perimeter settings. There we go. Okay, so we're into the spreader stuff. So next one, we have motor power and valve open. So spreader settings. Now, these are our last two in this tab here. So we're going to put our drone into spreader mode really quick. Okay. Now, we're going to do this broadcast. Same broadcast, but we're pretending we're using a spreader here. Altitude and speed, that's the same. The other two difference here are we got motor power and valve open, both shown as a percentage. Motor power is basically how fast the little spreader disc is spinning, and you don't get to pick RPMs or anything. I think somewhere in this operations manual later on, I have a chart of estimated RPMs versus percentage here, but most people just leave this at 100. This is basically going to dictate how wide the pattern is going to go. The faster this thing is spinning, the farther out everything is going to get spread. Now, this next one here, this valve open, is going to dictate your flow rate of those particles out the spreader. So basically, the farther along this is, there's a little gate that opens up that allows the particles to flow out the bottom of the spreader, and the higher this is, more is going to flow out. You get more flow rate. You get the idea. So that's motor power and valve open. Let's just see real quick what we have as a recommendation on that. I don't even know if we put that in there. We might not have. Yeah, I guess not. Yeah, I mean, basically just set it to 100%. It's going to depend. The application rates on dry chemicals is so different. If you're doing, say, like rye seed or something, or like tulip seed. I don't know. There's some of them that are turnip. That's the one I'm thinking of. Turnip, I think you're at like 2 to 3 pounds an acre. And the seeds are really tiny. So you're going to want that valve to like 20%, and you want to be spraying, spinner at 100%, because you really need to get those out. You're booking it as fast as you can versus something like, I don't know, like a micronutrient, maybe not like a pure NPK where you've got like 1,000 pounds an acre or something, but something pretty heavy dosage. Well, maybe you just put that the spinner at like 50% because you need it to be pretty narrow, and the valve's at 100 because you're really just dumping it all out over a smaller area. All right, so I believe that is it for our application settings. Just as a little reminder here, we went through, the first were these area settings, which is basically just dictating how these lines are going to go in the various different layer types. We did these area settings, and then we did the settings for that application itself. Here we got a fungicide, our altitude, speed, stuff like that for the application over those lines. Now we have our application here. We're going to put it onto a drone. That's all fine and dandy. And now we have the upload that. Now we have, lastly, the auto settings. So the mission settings, they're all kind of done and dictated, the actual pattern itself. Now we have the drone that's going to go and fly this mission. There are a bunch of settings. Oh shoot, we left it in spreader mode. Let's go and put that back onto the drone again. Make sure we're in sprayer. Okay, let's go back on the drone. Now we have a bunch of settings that basically go through how the drone is going to behave, how its autopilot is going to behave. There's a bunch of other settings. We talked about ferry and RTL and all that stuff that essentially don't really have to do with a specific mission. They have to do with the drone itself. And all of those settings can be found in the operations tab here. And we click our little drone settings button. This is where you find all of those. All of these settings, for the most part, are going to save on the drone. And if I go and I choose like a ferry altitude or something like that, and I save this, that ferry altitude is just on the drone now. Because you'll notice when we went through and say we do this other area over here, I don't pick the ferry altitude at any point in this process. So, the ferry altitude is just going to be whatever was on that drone. So, okay, that's fine. I put another application on this drone. Whenever that application finishes uploading here, it's not going to change any of that stuff. So, jumping into the first one, the first of these auto settings is that, again, that ferry altitude. So, how do we pick that? Is we go hit that settings button, and under this ferry tab, we have this little slider here. Ferry altitude. Now let's jump back over to our recommendations, down to our auto settings section. Ferry altitude, we recommend typically about 25 feet. That's a nice starting point to just get you safely out to the field. Really, this is going to be extremely variable based off of what is between the drone and the mission area. In this case here, we have this field over here and we have the drone over here. There is nothing between there's nothing in this open field, so there's nothing we really need to fly over. So there's no real reason to go higher than 25 feet getting out here. If you decide that you want to go up to 100 feet to get out here, all you're doing is burning a lot of battery, because the drone uses a lot of battery when it climbs up to these high altitudes. When the drone is fully loaded, like it would be during this ferry portion, it uses way more battery than when it is empty. So you really want to keep this ferry altitude low if you can. Obviously, safety is the number one priority. You need to make sure that, let's say if I was flying on this field over here, I want to make sure, so I'll make an application for this one, I'm going to want to make sure that my ferry altitude is going to be high enough so that my drone can get over this tree line here. So that's the number one safety concern when you are looking at ferry altitude, and when we get to RTL altitude as well, is what's in between the drone and the spray area. And you got to assume that this drone could come back home at any point during this mission. Obviously, it's an easy decision on this one, but let's say the drone was over here somewhere. It looks like for almost all the mission, we could just ferry at 25 feet, wouldn't be a problem. But you're unlucky. We're all unlucky. If the drone were to RTL back here in this corner, now it's cutting across this tree line. And you need to be over top of this tree line if you want to be safe. Otherwise, you are relying on your avoidance to keep you from hitting this tree line. At the end of the day, you just told your drone to fly into a tree. Not where you want to be. Avoidance works, but it's not perfect. So, you always want to make sure this ferry altitude is set to something safe. But 25, again, it's a decent starting point. Next one here, we've got our ferry speed. So I put as a recommendation here 16 miles an hour. This doesn't really matter too much. It's just going to, determine how fast you get out there. You don't want to be really slow, I guess. 16 miles an hour is a good starting point to, I guess I'll show you all where we get to that just in our settings there under ferry. 16 miles an hour is good. It's fast enough to get you out there. Once you get to be a little more experienced, you're going to want to increase this. The drone uses more battery the longer it's in the air. It doesn't necessarily use more battery flying faster. It uses a little bit, but at the end of the day, you are conserving battery going 25 miles an hour versus 16. Every day of the week, you are going to be more efficient flying faster to get out to the field, especially because you're heavy. You're using every second that you're out in the air weighing your maximum weight is going to burn a lot more battery. Now, the only reason you wouldn't right off the bat set it to this maximum speed is maybe you don't have a lot of experience, and if I RTL'd from here and I forgot to set my return height to clear this little patch of trees, well, maybe I'm going to be, I'm going to give myself a little more time to react if I made that mistake versus, if I'm going 16 miles an hour versus 25, you don't have as much time to respond to that. And also the obstacle avoidance, the slower you're going, it's going to have a better chance at detecting obstacles, especially small ones. So, I already said this, and I'll talk about it more once we get to the avoidance section, but the avoidance isn't perfect, and it's going to work better the slower you're going. If you are full tilt 25 miles an hour fully loaded and, a small stick jumps up in front of you, well, the chances are not going to be as good at that thing actually seeing it and stopping in time versus if you're going 15 miles an hour. So again, it's an experience thing. You'll increase it as you get better, but starting off 16 miles an hour is a good spot. Allow yourself a little bit of grace. So we did our very altitude, very speed. Now we're going to jump into some of the spray auto settings. So get back to our software here. So we got that ferry category. Next one is spray. So we're going to probably stay on this page while I explain it for a bit. Minimum flow rate. So this first one here, minimum flow rate, essentially is the lowest, the minimum amount that your drone is going to spray. Now, it's kind of weird. There's different flow rates all over the place. Why is that? Well, if I'm doing a dynamic 2 gallons an acre application, when my drone is at the edge of the field right here, it's going 1 mile an hour when it starts. Well, when you're going 1 mile an hour and using this gallons per acre dynamic rate, 1 mile an hour, the thing is barely going to be spraying. It doesn't call for a proper rate that's high enough to even activate all the nozzles usually. So if I get to that point at the edge of the field and I have this number at say 0.05 gallons per minute, this is generally not going to be enough to actually turn on all of the nozzles. So this minimum flow rate, a lot of the time you might want this a little bit higher so that at this field edge, it's actually going to crank it up to something that makes sense. Now let's see what we've got here in our recommendation. Auto settings minimum flow rate. So we have 0.4. So this increases as we get to the bigger drones that are spraying a bit more. But for the Ag 10, we got 0.4, 0.4 for the Ag 16 again, 0.5 for the Ag 30, and then we got some big 1.5 for the 72. Now, again, the reason for this is that 72 is big. It's got so many nozzles with those bigger tips on it that you need a higher minimum flow rate in order to kick on all of the nozzles. So that's what your minimum flow rate does, kind of how you'll pick it. If you find that on the field edges it's not kicking on as hard as you might like and it's dribbling a little bit, then you're going to want to go in here and increase that. So next one here, we had our spray speed. It's the same spray speed as before, just in case you want to adjust it on the fly without going back in here and messing with this stuff. We allow you to do that. Next one, spray descent speed. So spray descent speed is an interesting one and it can be a little bit hard to explain. So we're going to pretend that this drone, let's pretend that in the middle of this field there is a low-lying area. So in this area right here where it's kind of different looking on the screen, let's pretend this is low-lying and we have a blank patch, a bare patch in our field. Just because it's wet, corn didn't grow very well. So over the rest of this field, this drone is flying at 13 feet, and when it gets over this bare patch, essentially it was seeing 13 feet on a closed canopy, now it's seeing bare dirt. So the drone is going to drop down to readjust its height over bare dirt, and then it's going to get over the corn again because you selected a safe spray altitude so it could clear that corn. It's getting back in, but now the drone is a lot closer to the corn than it was before. And you're in this situation to where the drone is burning battery by aggressively adjusting its altitude for no reason, and it's just not quite as safe, and it's not going to lead to as even of a pattern when you get to this side and the drone is a lot lower than it needs to be. And when the drone sees that it's way lower than it needs to be, it's going to slow way down to correct its altitude and then keep going again. So with that in mind, we're going to imagine we got this bare patch. Essentially what this spray descent speed does, it is the speed in miles per hour that the drone will descend when it sees that open patch. So if this number is higher, we got a 3 mile an hour spray descent speed, the drone is going to very aggressively dip down when it sees bare patches like that. Or even just a simple, it's going downhill, it's going to track down that hill very aggressively. If you have this set super low, 0.5 mile an hour, then when the drone sees that bare patch, it's just going to cruise right over it. It will, descend, but not nearly as fast, 5 times slower than if you're at the maximum here. So, with that in mind, you depend on what kind of fields you got. If you got a lot of hills and you need to track down them pretty closely, in particular if you got power lines that you got to make sure you're getting under, so you want to make sure that drone is really, following that ground pretty close, you want this on the more aggressive side. You're going to want it a little faster. However, if your ground is a little more flat and you've just got open patches, that you want the drone to just be more smooth and straight in its altitude, or if you just see the drone kind of jumping up and down all the time, because it just does that when there's openings in the corn. It doesn't have to be a whole big bare patch. If you bring this down, it's going to smooth that out. So for most people, you'll probably want this on the lower end. Let me see what our recommendation is here. I think I had it around 1 mile an hour. Yeah, 1.1. So this is a little bit on the lower end. That's honestly where most people are, is a little more flat, or at least they would prefer to just ignore those bare patches and be a little more smooth. But that's how you're going to pick this. You got more hills, you want to track a little more close, you go a little higher. If you're pretty flat and you want to just go more smooth, you're going to keep this on the lower end. So next one here, we have our minimum spray speed. So this one has to do with this minimum flow rate here a little bit. Also a little confusing to explain. So minimum spray speed, you can see we just got a miles per hour number here. So miles per hour of basically when the sprayer is going to kick on. So when this drone is coming down here from the top and it's spraying, at some point this drone is going to have to kick off its sprayer. Now, when do you want it to kick off, basically? Do you want it to kick off when it's going 2 miles an hour and it's, kind of a little farther from the edge? Or do you want it to kick off at 0.1 miles an hour and it's not going to kick off till it's right here near the edge? Now, you might all say, oh, I want to kick off at 0.1 miles an hour, which I would understand. If you're doing herbicides, though, it might not always work for you, because essentially the drone takes some amount of time to stop. And if you are waiting until you get to 0.1 miles an hour and you are right up next to that edge, then the drone is going to keep spraying at this minimum flow rate that we talked about before. It's going to keep going at a half a gallon a minute right up until that last second when that thing stops dead. And you're going to end up over applying on this edge right here. So depending on what you want to do, you probably don't really want to over apply, but the faster, the lower this number is, the more you're going to over apply a little bit on that edge. The higher it is, the less you're going to over apply. It's not going to be perfect, just because, the way sprayers work, you got to have some minimum rate that you're spraying, and that's not always going to line up with, what your gallons per acre should be. Just kind of the way of the world. The drone can't, in zero time jump up to the actual speed that it wants to be at. It's going to take some time. So that's kind of how you massage, what you want out of that trade-off. And just stopping is only one side of the equation. Starting up is the other side of the equation too, because that spray speed is minimum speed is used to determine when you kick off that sprayer and also when you kick it on again. Because now it needs to kick on again, has to get to a certain speed before it starts up. So what do you want that to be? Again, if it's 0.1, then it's going to start spraying immediately, which is good for a lot of occasions. Fungicide, for example, most people have this down at the bottom. Herbicide, though, you're over applying again. But if you have it set pretty high to say like 3 miles an hour, it might not start spraying again until it gets out here a little bit farther from the edge. So we'll pull this back up, see what we had as our minimum spray speed. Okay, yeah, I have here at half mile an hour, so that's pretty good, kind of middle ground. Half mile an hour. Again, it's on the lower end because we generally see people using these drones for fungicide on corn. That's probably our number one use case. So that's kind of the recommendation that we're looking at here, is making sure that you're spraying enough, half gallon a minute, and minimum speed pretty slow. So what that results in is erring on the side of over applying as opposed to under applying. So if you're looking at herbicides where it matters a lot, where you're over applying, you might, these recommendations might not be best for you. This recommendation here is a little more so for a fungicide, where you just want to ensure that you get coverage. All right, so I think that might be it for our spray settings. Let's just double check up here. Yeah, so we got through our spray ones. Now we're going to get into our RTL settings. So again, we just got to this settings tab here. We're in the operations tab. We hit settings, go to RTL. Now we're looking at RTL. So first two, pretty easy. Very similar to our ferry. We've got RTL altitude and RTL speed. So essentially the exact same as ferry, just in reverse, and the same logic applies as far as how to pick them. So, RTL, you need to essentially look at every last corner of this field, and you want to select an RTL altitude that's going to be high enough for this drone to make it back home. If you don't do that, then you're essentially relying on your avoidance to keep you from hitting this tree. Now, there are some situations where, maybe you got a windmill or something that maybe it's not really possible to go over top of it. We'll talk about that a little bit later. There's some other more advanced settings that can help out with that. But for now, all you need to know is I'm choosing my RTL altitude to clear anything so I can always get home from any point in the field. Because again, you are unlucky. We're all unlucky. You're, of course, going to RTL from this last corner here. It's just how it goes. And same thing for speed. We've got RTL speed, same thing's ferry. There's no real reason to be going slow. I'm sure I put the recommendation at 16.5 miles an hour, probably the same as I did ferry. For the same reasons, you want to give yourself some grace, especially when you're new, to catch yourself in case you made a mistake. But once you're a little more confident in your abilities, confident in how you're flying your checklists, making these missions, then you can start to speed that up a little bit. All right, next one's here. We've got our lost link returns. So we have GCS lost link RTL, RC lost link RTL. Really, all of the rest of these RTLs, GCS, RC, area, volume, and empty tank, all of these are conditions to when you would RTL. So again, RTL is the returning home to land. Now, you're always going to return home and land. You're going to enter RTL mode if you finish the area. Obviously, in this mission here, this is a very big field. We're not going to finish this in one flight. So you're going to be coming home for some reason. So what conditions would you come home? That's kind of what these next little switches are. First one, GCS lost link. So if this is turned on, the drone will return home if it loses connection with the computer here for 10 seconds sustained. So according to the FAA, this should be on all the time. So leave it on all the time. But there may be some conditions where it may be more safe to leave it off for whatever reason. Just kind of up to your discretion. The recommendation on this one is to leave it turned on. If you're losing connection frequently, we recommend to just increase the height of that antenna that plugs into the computer. A few different ways you can go about doing that, increasing your range. That was already discussed a little bit earlier in the manual here. But yeah, basically just, do you return home when you lose connection to the computer? Yes or no? If you have this turned off and you do lose connection to the computer, though, bear in mind, all of this mission stuff, all of these settings, everything is saved internally on the drone. You're just changing settings that are on the drone. So it's still going to do all of this stuff whether you're talking to it or not with the computer. But that's what that one does. Next one, similar thing for the remote controller. So do you return home if you lose connection to the remote controller? Yes or no? Again, we recommend having this turned on. Again, according to the FAA, this should be on all the time. The reason you might have this turned off is if you're going pretty long range. The computer has better range than the controller, usually. A lot of the reason for that is you can get the computer antenna 20 feet up in the air to have a good line of sight to the drone. Can't really do that with the controller. If you put the controller 20 feet in the air, what good is it to you? So some people that like to have their controller on all the time, just to be able to monitor the video feed and stuff like that, but they're going kind of far away, you might want to have this turned off just so you can fly out of range of the controller, but when you do, then it can come back in range and you can still be able to take over really quick if you want to. You don't have to turn the controller off before you take off or anything. So this one, you're supposed to have it on all the time, but that's what it does. The GCS loss link, it RTLs if you lose connection for 10 seconds. RC loss link's a lot shorter. I think it's maybe 1 second, like really short. Reason being, if you were flying it manually and you flew out of range of the controller going manually, it's not going to hesitate to bring that thing back home, because otherwise you have a situation where it just flies away. So that one turns over really quick if you got it turned on. Next one here, we have area RTL. So basically what this does is, if I were to start flying this mission here, this drone, when would I want it to return home? I could have it return home after flying, say, 2 acres. If I've got this one to help explain a little better, we'll jump into our recommendations here. All right, so we got our area RTL, and this is assuming we're doing 2 gallons an acre. On the Ag 10, you want to return after 1.2 acres, because that way you still have a little fluid left in the tank, and you're coming home. Ag 16, you want about 2 acres, same reason. Ag 30, so you've got 8 gallons, you want to return home at about 3.8 acres, so you're having about a quarter gallon, half gallon left. On the Ag 72s, we recommended doing 3 gallons because it's a good rate for that drone. That puts us as about 6 acres. So, this is going to depend on what your application rate is. But generally, you're going to set this, and you can do the math so that the drone returns home with some left in the tank. So that's area RTL. Next one, we got volume RTL. Similar sort of thing. This one can be used if you're not using the flow meter, for example. Or if you are using the flow meter, you can use volume RTL. You would prefer to use area RTL if you aren't using the flow meter. Kind of got that backwards. But it's a similar sort of thing. Volume RTL, volume limit, is basically if I've got an Ag 30 that's got 8 gallons, I can tell the drone to return at 7.7 gallons. And the reason I would do this is so that I'm not getting air in the lines over and over, and I keep having to purge the tanks, because if you've used these drones more than any drone really, more than a month, you'll see that if you're constantly getting air in the lines and you got to purge air all the time, you got to go open valves and stuff, it's a pain. So you're better to just return home a little early. That's what volume RTL does if you have it turned on. And then last one, empty tank RTL. So the Ag 72s have a physical empty tank sensor. The 2 series of the smaller drones also have an empty tank sensor that can read the fluid volume. The empty tank sensor is not perfect, because honestly, just because the drone tilts, and if the drone's tilted forward, the empty tank sensor is only on one side, so it's not going to see it perfectly every time. Basically just reads when it thinks the tank is empty. It's not always the most reliable, to be honest. It generally either relies on just the tank running totally empty or kind of close to empty. If it doesn't work, you're going to find yourself running the tank dry, and we're kind of back to that pain again. So we generally recommend to use area or volume RTL, even though you could use the empty tank RTL. So just jumping back through we have our volume RTL. We had that turned off. Our recommendation was area, just because that's my favorite, but you can use whatever. Empty tank RTL off, as we discussed. And then our last auto settings here are the OA settings. So obstacle avoidance, basically turning this on or off, and then our obstacle margin. Again, we'll get into avoidance a little bit more detail later, but obstacle margin is basically how far away this drone will try to stop from objects. So if I have it set to something pretty far, let's say I have it set to 45 feet, this drone might get up to this part here and decide that, ooh, that tree is a little close, I'm supposed to be standing 45 feet away from stuff. So you could see how that might cause us some problems. So, that margin you can kind of massage based on what you're doing. A lot of people like to keep it on the lower end. Let's see what we got here on our recommendation. 25 feet. Yeah, that's about a good spot to be at. Kind of keep 25 feet away from stuff. If you're getting closer than 25 feet to things, trees, stuff like that, I'd say you're cutting it a little bit close. All right, so we got through most of these. That was all of the auto settings. Last little chunk here is the manual settings, and that will have put us through all of our recommended settings chart. All right, so manual settings, similar to auto settings. Here, let's go ahead and land that drone really quick. We probably didn't set our RTL to a safe level over those trees, so I'm gonna go land over here. It's a simulator, so it's not gonna fly into anything, but out of principle.
Drone 1, returning home.
All right, so drone is returning home. Now we're gonna go, and you notice that while we're flying, we could not change the ferry and RTL settings. We couldn't change the spray speed either, but we could change just about everything else. So it's important to know, what you can and can't change while the drone is already in the air. But anyway, that was all for when we're doing an auto mission. We're following a mission that we talked about. Next one here is the manual settings. So this is when we are using our controller here. I'm flying around with the sticks. I'm pressing the spray button, whole deal here. Going to just have some settings for how this thing is going to fly. So first ones we've got are our spray mode and spray rate here. Same exact thing as before. In the auto settings, we can pick say 100% pump power. Then basically what this first couple of settings does is when you press this button, the spray button on the controller, what is it going to do? If I press that button and I'm on fixed power 100%, then I press it, it's going to do fixed power 100%. If I do static to whatever, that's what it's going to do. If I do dynamic, it's going to say I do 2 gallons an acre. Now I get some settings here. Okay, I'm planning on doing a 20-foot swath width. Then when I press that button, it's going to spray based off of my flight speed. This is important to know. If you have this controller in dynamic spray mode and I'm just parked on the ground and I press this button, nothing is going to happen. That drone is not going to spray. Reason for that is it's not moving. It's trying to spray 2 gallons an acre, but its speed is 0. If it's not moving, then it just doesn't make sense to be spraying 2 gallons an acre because it's spraying infinity gallons an acre because it's not moving. So generally, we send out the drones with this in fixed 100% because it cuts out a lot of phone calls because people are forever calling us. I press the spray button, nothing's happening. So we resolve that by sending it out on fixed. But if you are doing a lot of application flying by hand, I would go and probably change this to dynamic and use that. Next one here is we have our speed limit. So that is if I am going full tilt forward, just I hold this stick up, I'm flying maximum. How fast is it going to go? So again, I think we send this out pretty low. We probably send it out 3 or 4 miles an hour just for new people to make sure that they don't, turn that thing up and it goes 15, 20 miles an hour, be a lot harder to control. You'll want to use this, especially if you're doing dynamic and you use that maximum speed calculator. That's where this can come in. You can use this to make sure you don't fly faster than you need to be. So this is good. Really, we'll check what my recommendation is here on this one, but it's pretty slow, I believe. 5 miles an hour, just to make sure you're being safe. Especially for new folks, there's not much reason to be flying faster than that. Next one's here, obstacle avoidance. So you have actually 2 forms of avoidance. You've got your avoidance in auto mode, where the drone is generally just going to fly up to stuff and stop. You can have different settings for avoidance in manual mode in case you want to. So you have the avoidance turned on or off, and you have a margin. Really works the same, just allow you to have it on in one mode and off in the other in case you want to. As long as you know what you're doing, there's not necessarily any wrong answers on this. I would kind of recommend keeping it turned on. Just as always, having your obstacle avoidance on is a good thing. And yeah, that's it for the manual settings. So on all of this stuff, I can go through and change a whole bunch of things, and whenever I'm done here, I just click update and it goes out to the drone. All right. Moving on to our advanced flight settings. So you'll notice here, all of these are turned off. We're going to talk a bit about each one of these. I'll show you where to find them and what they all do. Now, we're almost done here, wrapping up. This will be a long video. What I tell you at the beginning, we might be an hour and a half on this one. We're going to go through these advanced settings, and we're going to talk about kind of making efficient missions really quick, and then we will be all wrapped up. So, advanced flight settings, we're going to take on in order of importance here of that you might actually use them. We'll get to the end, and we'll be very brief because most people won't use them. First one here that we're going to talk about is RTL denied. So I'm going to pull up the software and show you where these advanced settings are. So this was all our normal settings. Our advanced settings, you got to go to the maintenance tab. So you go to the maintenance tab. They are right here where I'm behind me on screen. Advanced settings right here. So start from the top, RTL denied. What does RTL denied do? We talked a little bit about, so here we can actually show it in action. We turn on RTL denied, okay. Let's go ahead and take off, and we will set a RTL that'll happen really quick. So we'll do an area RTL of 0.2 acres. So this thing is going to get out there, and it's going to start spraying. It's going to pick off wherever it left off. It's going to take a minute here. Whenever it goes to RTL, for whatever reason, be it low battery, or say this RTL that I just set, or any other RTL that I have set here, lost link, yada yada, any of these switches or low battery, instead of coming home, the drone will pause and it will just stop in place and it will wait for you to tell it what to do. So we'll see it pretty quick here, and it'll make more sense in a second. Now, the reason people like to use this is because, let's pretend this tree line here, instead of being 20 or 30 foot trees that I would just fly over, let's pretend we're in California redwoods forest or something, and these trees are 200 feet tall or whatever it is. We can't RTL over that. I mean, we could, but we might run out of battery going that high. So instead of, setting an RTL altitude over the top, we're going to go in here and just turn on RTL denied. And now in this case, where the drone were to RTL, it instead just stops and it tells me, that I'm paused and now I can go moving around. I know this is kind of confusing, but basically anytime RTL denied is turned on, the drone does not RTL until you explicitly tell it to. And the reason you would do this is if you cannot go over an obstacle. Essentially, when you are flying back home to your land point, you have two options. You're either going to go over the obstacle or you're going to go around the obstacle. Or I guess the third option is you're going to try to fly into it. We're not even considering that as an option. You got to go over or you got to go around. If you're going over, you have to set that RTL altitude high enough to clear anything on the way home. You pretend, you got this dotted line. You got to pretend you could come home from anywhere in this whole field because, like I said, you're unlucky, just like the rest of us. You got to assume you can come home, and you got to set that altitude high enough. For whatever reason you can't do that, you're going to want this RTL denied switch turned on. And, like we're seeing here, the drone were to RTL for area. It'll do the same thing for battery, for anything. It's just going to stop. Because the drone is assuming you turn that switch on because it was safer to just stop and sit there as opposed to potentially go and try to fly itself into a tree. Again, relying on your avoidance to stop it. Now, in this situation, generally what you would do, the drone has now stopped itself. We can use this fancy little flag tool here to fly the drone. We don't have to get the controller out. We can just use our computer here. Here, I'll fix my angle so this will be a little easier. Basically, we just fly our drone to where it has a safe angle. Okay, now we could see from our dotted line, we're clear of this tree line. Now we can click RTL. If we actually click RTL, it will do it.
Returning home.
But it doesn't do it automatically. So, again, RTL denied switch. This is the most important switch here, advanced switch, because people use this quite a bit. It just stops the drone from RTLing. Now, when you have the switch turned on, you're going to want to pay a little extra attention to what you're doing, because if you have it turned on and you are eating a bag of chips or something and you're not paying attention and that drone just sat out there in that field for 4 or 5 minutes, it's going to sit there until it runs out of battery and it's going to land in place. Because like I said, it even does this for battery RTLs. It doesn't just do it for, area and stuff like that. It even does it for battery as well. So you get low battery, that drone is just going to go and sit out there until it reaches that critical battery level and it's going to land in place. Now, again, landing in place, generally not going to cause a lot of damage. It's going to cause a lot of work because you got to go out and grab it. But at the end of the day, not a whole lot of damage. We at Hylio consider that better than being in a tree. So, RTL denied, you're going to want to use that. Just remember to draw that invisible line from the entire area here. I'm going over or I'm going around. You got to be one or the other. And if you're going around, you're going to want to use this RTL denied. All right, so that's our first one. We have a whole section. I probably just touched on almost the whole thing already in the UAS safety about how to use this and make sure that you're safe, that whole over or around thing. I'm going to go over it all again because this is probably one of the most common, if not the number one most common causes of drone crashes, is not understanding this and utilizing this, RTLing into stuff. Especially because you'll get up going to that 25 miles an hour. You just have like a little stick or something. Gives the OA some a hard time. Next one, pilot altitude adjust. So second switch here. What this switch does is if you are flying in an auto mission, so I'm flying through this pattern here, and I have that switch turned on. If I press this throttle stick up or down, it will adjust the altitude of the drone in flight. So we are, we're halfway through this mission here. We're going to go and fly again. And we're going to break our cardinal sin. We probably didn't set our altitudes right. This thing's probably going to fly through that tree line. Here, why don't we just, out of principle, we're going to fly it around. I just hate watching a drone fly through a tree line. Here, it doesn't let you do it too far. Okay. All right, I think that's probably good. There we go. Let it resume now that it got there. Anyway, so it's going to go resume. Once we're out into the spray area, we're flying at, say, 13 feet or something like that. We want to fly at 15, but we don't want to go through this whole process of doing the application again and all that. If that switch is turned on and the RC is on and within range, you can just bump up that altitude or bump it down. So if I just press this up a little bit and it climbs up from 13 to 15, it's just going to stay at 15 for the rest of the mission. Now, when it goes to RTL, if it were RTLing at 25, it's going to RTL at 28, just a little bit higher, whatever you did. So, important to know, just making these little adjustments on the fly. It just holds it for the rest of that flight, and when it goes and lands and takes off again, it's reset to whatever the mission was. So, if you want to do that, you can have that on or off. Now, next one. We got spreader. So we already looked at this earlier. I want to land this drone because it might not let me mess with some of these while the drone's in the air. Oh yeah, it's not letting me do any of these with the drone in the air. So good thing to know. We just put her back on the ground. Okay, nice. So spreader, basically turning this switch on or off, tells the drone if you have a spreader attached or not. So it knows what signals to send out. So you can physically put the spreader on. If you don't turn this switch, then it won't send out the commands to actually activate the spreader. So pretty simple. You got a spreader on, you just turn that on. Next one here, pump auto arm. So this one is interesting. Depending on the drone that you have, you may want this on versus off. Basically, all of Hylio's drones nowadays don't need this turned on. It's part of like a pump boot up process for drones shipped out, 2021 to 2022, and not all of them either, just some of them. Basically, if you have an older-ish drone and when you go to spray, the pump doesn't start, And not because you have air in the lines or anything like that. It's not even trying. It may be because you need this switch turned on. It's just part of a boot up process for some older drones. If you got one of those, you probably already know to use this. So if you're watching this video and the drone is kind of new for you, just leave it off. Next one here is terrain denied. So terrain denied, basically, and you saw what it said there, if I turn this on or off, it's going to clear the application. You need to turn the drone off and on before this actually applies, before you can take off again. Terrain denied essentially uses the barometer instead of the radar for altitude. So if I were flying over this tree line here, I'm using my radar, I'm 30 feet off the ground. I fly over those trees. Now it sees the trees is only 10 feet under it. It's going to adjust up to be 30 feet, which is good and bad. If you use barometer, it basically, any altitudes throughout the whole mission, so we're talking RTL, spray altitude, whatever, instead of being in the reference to the ground beneath it, it's going to be in reference to the altitude, like based on sea level of where you took off. So it does not respect hills. It doesn't respect anything like that. It just, if I say 10 feet, it's going to be 10 feet above this takeoff location, and that's it. It just stays at that height. And if there's any hills, it does not adjust for hills. The reason you might use this is if for whatever reason you're doing some really high altitude applications, the radar rangefinder starts cutting out right around, I think, 30 meters. That's 107 feet, somewhere in there. So if you are flying higher than 107 feet, which I really don't recommend for almost any occasion, but you might have to for various mosquito applications. There's different reasons that you might need to, but if you're doing that, I would recommend switching to terrain denied, because the radar is not going to work once you get way up in the air like that. For most people, you're not going to use this though, but if you do, just be careful. It's not going to be as accurate as the radar by no means. It can be off by a few feet. You're talking about changes in air pressure of like a tenth of a decimal, or 100th even, changes of air pressure, for it to know perfectly. Like this stuff is used by airplanes to tell if you're at 10,000 feet or 9,000 feet, not to tell if you're at 12 feet versus 15 feet. It just doesn't work as well for these like really small altitude changes. And you get something like a storm rolls in, the air pressure just changes because you have clouds and stuff. All of a sudden, you're relying on this changing pressure to know your altitude. So really wouldn't recommend using it. I would only recommend it for more advanced people, hence why it's in advanced settings. Next one here, we have look ahead yaw. So when the drone is flying along this shape here, let's go and put this back on a drone. When it's flying along, it is essentially going to do a little crab scuttle as it goes down this line, and it turns and goes back up. It's not going to turn its nose to follow where it's going. It's just going to shuffle along. If you want it to turn its nose, then you can turn this switch on, and then it's just going to face forward all the time. Now, don't really, recommend this for most applications. It uses a surprising amount more battery turning all the time like that, so it's not as efficient. The only real reason you would use this is if you have some specialty application or some funky cameras on there. We only put one FPV camera that only faces the front, so that could be one reason. You just want video feed, facing forward all the time. Totally understand that. Personally, I don't think sitting there and watching the video feed saves you from anything. If I'm trying to watch the video feed to see if I went too close to clipping this tree, I guarantee you that you're going to just clip that tree before you're able to do anything about it watching the video feed. But, that's my personal opinion on the matter. But, yeah, that's if you want, to face forward all the time, that's what look ahead yaw is for. Next one, spot rotate. So when we talked about this spot mission, that was in area 2. Whenever you are parked over top of this, let's say you're spraying a half gallon because you just want to burn that spot down. If you have that switch turned on, the drone will rotate in a circle while it sprays to just kind of help the pattern spread out a little bit more even. Now we got GPS denied. I would not recommend using this. This is for those 2 or 3 of our customers, or maybe 10, really not very many, that are flying inside of stadiums, inside of buildings, stuff like that, where you have no GPS. You can only use manual flight control when you're doing this, and the drone will not maintain its position at all. You get a gust of wind, it's just going to get blown all around. So this is really only for experts. I would not use GPS denied unless you really know what you're doing, and when you do, you're only flying manually. So won't recommend doing that. And then last one, camera trigger. This, again, another specialty application. Again, that's why we're in advanced settings here. Specialty application of, we have the ability to trigger certain external cameras, DSLRs, stuff like that. Other devices don't really recommend using that unless you are one of those customers of ours who has some special device on there. So that was the advanced settings. Just, really RTL denied, and probably pilot altitude just to be the ones that you'll ever take a look at if you're one of the 95% of our customers. Next, and our final section before we are done on this crazy long video, is just a general discussion here about some efficient missions. So we talked about what all of these different settings are. We haven't really talked about efficiency too much. So just first thing, we've got this ferry and takeoff point. So we're going out to this field here. Just something to be aware of. It's going to be really inefficient taking off and landing from this point over here. Now, I understand maybe this is your farm and you're doing all of these fields. You're doing this one, and this one. Maybe it's your access point right here is going to be the easiest for you to get to. I get that. But this entire length right here, if you look at that, that's almost the length of an entire pass up and down this field. You are surprisingly less efficient. I mean, way less efficient being way out there versus taking off and landing out in here. So I would just take this into consideration when you're looking at your setup locations. Obviously, we're in the middle of a field here. We can't do this, but just take some time to put this takeoff and land location as close as you can. You're also going to want to put it at a point where, okay, if I could choose anywhere along this bottom part, if I'm right here, I don't have to worry at any point in this mission about this tree line at all. I don't have to worry about going over top of it. But if I'm right here, now all of a sudden I'm good here, but I have this one nasty little corner here that now I have to RTL and ferry from way up in the sky, or I'm just asking for trouble. So even something simple like this of moving your takeoff and land point just, this 50 yards to over here, all of a sudden you are tremendously safer. And just, from a statistical perspective, you go out and you're spraying, 10,000 acres or something. These little things about just these decisions are going to make a big difference, in the long run about minimizing accidents and just increasing efficiency. Next one, we already talked about this a little bit, ferry and RTL altitude. So just not ferrying and RTLing crazy high, just going to be really good on your battery and, as far as the total mission time. Just like it takes a long time to ferry out, half a mile or something, climbing up and then ferrying a half a mile just takes a ridiculous amount of time. There's not ridiculous, but it takes a long time. So there's not really a whole lot of reason to do that, unless you have to get over some particularly tall stuff. Next one, this ferry and RTL speed. One last note about this. If you are, we talked about that recommendation being 16.5 miles an hour. If you are ferrying or RTLing farther than, say, a quarter mile, so I don't know what that would be. So we can zoom out. The software will tell me here. So that's quarter mile. It's probably like half mile down there. So if we're ferrying RTLing farther than a quarter mile, you're probably going to want to start really jacking up this ferry and RTL speed. Especially if you got some wide open area, it takes a while. You got a half mile to go and you are ferrying RTL and a few miles an hour slower, it does not do you any good. So really want to jack that up. If you're going more than a half mile, you need to start paying attention to your battery. So like we talked about before in the battery section, we're just going to reiterate here, the drone does not have intelligent RTL, does not have intelligent battery RTL. So if you're more than a half mile away, that battery RTL cutoff, that voltage cutoff, is really not intended for these really long hauls back. So if you're starting to do that, you need to pay attention to your battery. And then last one, it's not really recommended going more than say 3/4 of a mile. Even if you're, in the best cases, you got your ferry and RTLs maxed out and speed at least maxed out. You're going pretty low. I've seen people push it to a mile and be okay on battery if your batteries are a little newer, but just overall efficiency standpoint, you want to do the most you can to put yourself in a position to be better for your batteries, better for safety, just your own hair going gray, not having to worry about it as much. Intelligent RTL, this is an interesting one, especially if you're more advanced of a pilot. So let's say we got these like half mile runs here, we're working on a quarter section or something. We got a half mile run down and back. If we're looking at this, and depending on my tank or whatever, what drone I'm using, maybe I've already sprayed out 2/3 of my tank just going out here and coming back here. You might be pretty better off to just land it right here. So you're not ferrying all the way out there. You just went out, went back. I sprayed like 6 gallons or something. I land it, and now I take back off, and I'm just ferrying out right here. Because if I run this thing empty, now all of a sudden I'm going to go empty right here, and I got to ferry all the way back, and then I got to load it and ferry all the way out. You end up less efficient doing that than just RTLing a little early and just topping off the tank. So just something to keep in mind, use your own kind of intelligence here. We're working on getting some of that intelligence built into the machine. For now, it's not in there. You got to use your own intelligence as much as you might have. Try your best. Same thing really applies for battery voltage, all that stuff. Next one here, so spray efficiency. Again, I'm harping on it. Use the spray speed calculator. Use it. If you don't, you're just going to either be not as efficient or you're going to underspray. So do it as much as you can. Spray at the lowest volume that you're comfortable with. If even going from say 2 gallons to 3 gallons makes a huge difference on drones as far as overall efficiency. So, you're going to want to, as much as you can, try to edge that down. And aerial label is generally, 2 gallons for everything. If you're in a foreign country or something and you don't have labels to worry about, if you do go down to 1 gallon on, say, a fungicide or something, that can get very efficient very quickly. You can imagine spraying at 1 gallon versus 2, twice as much out of each flight. Stuff like that, when you're looking at some of the bigger drones though, an Ag 30 all the way loaded up 8 gallons or an Ag 72 at 20 gallons. If you try to spray some really low application volumes though, you need to start looking at your battery again, because an Ag 72, if you want to fly that thing over 20 acres, you're not going to be able to do that on one set of batteries. So just something to consider. Last couple here, terrain. So if you got a lot of hills, just flying a little higher, a little slower, it's going to lead to a little more efficiency, just not having so many stoppages when you're close to hills. If you do have some hillsides, it's generally better to, if you imagine this hill is facing, I guess, this way, you want to fly along the hill as much as you can. It's up and down it, because going up and down burns a lot of battery. Way more battery than going side to side. Going up and down really burns it. Then last one, ground station. So just general efficiency. We already talked about this quite a bit. Just get that ground station set up for, especially if you have smaller fields, you want to focus on the ability to set things up quickly, or just the location can make a very big difference. All right, so this was a fun video, really long one, and it kind of got us into the software a little bit. Like I said before, don't use this as a how to use the software video. We're just kind of showing you guys where each of the settings are to help explain them a little bit better. Go to the software video, watch that one to really understand how to use all these things. Seems like a lot. I would go through and review it. as much as you can, practice changing each of these things. Use these examples. I know it looks like a whole lot. It's really not that much if you kind of get into it. Most of it's really already set for you. But if you're having trouble, just sticking with these recommended settings is always a good place to start. But thank you very much for watching if you stuck all the way to the end of this video, and I will see you in the next one.